Section 3.7 is on page 258, talks about optimization problem. That's a maximum and a minimum. But here, there's a slight change. In the previous section, they gave us more information than they're going to do in this section, but we're going to follow the trend of the previous section. That is, when I start the problem, I need to figure out what is it that I'm trying to maximize or minimize. In this case, find two numbers whose difference is 100. Let's say x and y. Let the first number be x, let the second number be y. So x minus y is 100. And whose product? So if I was to choose the first number to be x and the second number equal y, isn't the product xy? Whose product is a minimum. I want to find the minimum of this product, so I know how to do that. I'm going to take a derivative of that. The catch, there are two unknowns, but this is a system of equations. If I solve the top equation and say x equal 100 plus y and substitute that value in there, then out of those, my product turns out to be x times y, and we already established that x is 100 plus y, or I could simply say the product is 100y plus y squared. And now it's a matter of finding a maximum. I know how to find a maximum. I'll take a derivative. That is 100 plus 2y. Set it equal to 0. That means y would be negative 50. And let me see how that works. If I do my testing, if I pick a point to the left of negative 50, there's the product. Say, to the left, say negative 52. That will be negative 1 of 4 plus 100, that's negative. And if I pick a point to the right, say 5, that will be positive. So this would be a minimum. That would yield, I have a minimum, what? This is P prime, minimum product, when x equal and y equal. We got y to be negative 50, and do we know what x equal? 100 minus 50 is 50. And there it is. Let me move down to the next problem. So that would be my answer. Problem number 8 talks about a rectangle. Well, let's look at a rectangle. Here we go. Here's a rectangle. So pretty much the same as what we did before. There are a couple of minor things, just that you're going to have to find things in terms of variables. Find the dimension of a rectangle, whose area. This area is 1,000 square meters, and whose perimeter is as small as possible, 2L plus 2W. If this is L, this is W. There it is. Again, this has two unknowns. I want to get rid of one of those. So if I look at the top, I know what the area is. Area is length times width, and that's 1,000. So I need to get rid of one of those. It doesn't matter which one. Since I want to find a maximum, a minimum perimeter, I'm going to take the derivative of the perimeter and set it equal to 0 like we did. P equals 2L plus 2, and instead of W, I'm going to say W is 1,000 over L. Substitute this value right there. And the perimeter will be 2L plus 2,000 over L. And if I take a derivative of that, so now if I take P prime, that would be 2 minus, this is really 2,000 L to the negative 1 minus 2,000 L to the negative 2. And if I set that equal to 0, then that says actually two things. Where does, here, let me combine those. There. So out of this, where does p prime equal to 0? Where does p prime not exist? Well, it doesn't exist when the length is 0. So yeah, you want to make it as small as possible. Don't create it at all. That's meaningless. And where does the top equal 0? That's 2 into L squared minus 1000 equaling 0. That's when L equal plus or minus 1000. Length can be negative. I'm sorry, not 1000. Square root of 1000. So when I want to do my testing, I would say, you know what, I should have put this up there. Right there. So, if I take my, there's p prime, there's the perimeter, I want the square root of 1000. Well, to the left, if you don't know what that is, you could take half of it, or you could just take 1. The denominator is always positive. If I put a 1 right there, 2 minus 2000 is negative. To the right, I could put 1000 instead of square root of 1000. 1000 squared, oh boy, that's a million. 2 million minus 1000, 2000 is positive. So I have out of this a minimum parameter when the length is the square root of 1000 and the width is, and let's see what that is. That's 1000 over radical 1000, which is square root of 1000. Each of those is in meters. So that would be my final answer. Okay, next problem. A box with a square base, well, that's traditional. That's the base. You could call it any variable you want. Oh, that doesn't look pretty at all. Let me redo that one more time. I want it to look better than that. There we go. A box, call this Y. A box with a square base and open top is to have a volume. The volume is 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material work. The amount of material, that's area. The surface area would be what of this box? Area of the base. Area of the base is a square. They said an open top, so the top is open. Plus, if I look at this area right here, isn't that length times width, x times y? And there's 1, 2, 3, 4 of those. The problem with that, as usual, there are 2 unknowns. I want to get rid of those. Well, that's where volume comes in. Volume is what? Volume is length times width times height. X times y equals 32,000. So it's easier to solve for y and say that's 32,000 divided by x squared. Take this and throw it right there. And my s, you know what, I'm going to shift to the left. So my s is going to equal x squared plus 4x, and instead of y, I'm going to throw in the value of y, which is 32,000 divided by x squared. So s is x squared plus 4 times, what is that? There it is. That's my equation. Once I have the equation, I know what to do. I'm going to take a derivative. S prime is going to, you know what? Let me make use of this. If I take s prime right there, that would be 2x minus 128,000 over x squared. And s prime is going to equal 2x cubed minus 128,000 all over x squared. So if I was to ask, where is s prime equals 0? Where is s prime not exist? When the denominator equals 0, well, that's when x equals 0. That's useless. You know, just don't create the box, and it's really the smallest. If I factor a 2 out of the top, So I'm looking at where does x cubed equal 64,000, and if I cube root both sides, I'll get x to be 40. So if I do my testing, there's 40, there's s prime, and there's s. If I pick 1, plug 1 in there, 2 minus 128,000, it's obviously negative. And if I pick number bigger than 40, this is gonna be definitely bigger than 128,000. That will be positive. So in this case, we know that we have a minimum surface area when x equal 40 centimeters and the height y equal, and what is that? If I put 32,000 divided by 40 squared, 1600, 2 zeros cancel out, that's 20. That's acceptable. Or you could say we have a minimum surface area when we have 40 by 40 by 20 centimeters. That works as well. Next problem up is number 20, and it follows in the trend of what we did already, again with another minor exception. Show that of all rectangles with a given area of a rectangle is length times width. That's the width, that's the width. Show that if you're given the area, if this happened to be a number, they're not going to tell you what that number is. The one with the smallest perimeter is a square. The perimeter is 2L plus 2W. We just did that problem. And what are we going to do? We have to get rid of one of those. Let's get rid of W. If I want to get rid of W, W will equal A over L. If I am to say the perimeter is 2L plus 2, and W is the area of, remember, area is a number in this case, because they said with the given area, so that's whatever that is. The perimeter prime would be 2 minus, and this is like a, remember, this is the only variable that's a constant, 2a you leave alone. Bring the power down, subtract 1 from the power. The perimeter will be 2L squared minus 2a over L squared. And the same as before, we would like to figure out where does P prime equal 0? Where does P prime not exist? It doesn't exist if the length equals 0. Well, that's useless. Or if 2 into L squared minus A equals 0, that's when L squared equals the area and L equals the square root of the area. So if I do my testing, there's the square root of the area, there is P prime, and there's P. So if I pick a point to the left, let's say I pick, now for testing, I could pick square root of A over 2. If I throw that in, remember the denominator is always positive. If I put that right there, I'm looking at 2 times, when I square that, that's A over 4 minus 2A. This cancel with that 2 times. A over 2 minus 2A. This is definitely negative. If I factor an A out of it, area is always positive, right? So if I take A out of it, 1/2 minus 2 is negative. And if I pick a point to the right, that's easy, twice radical A. And if you put that in there, I'm looking at twice, if I square this, that will be 4A minus 2A over, and that's positive, I'm just looking for plus or minus, that's 8A minus 2A, that's 6A. And this was negative 3/2 A. So that's positive, it's increasing. So we have a minimum, actually we're not going to say minimum, we're going to say what they want. We have the smallest perimeter when the length is radical A. And how do I find the width? Right there. The width would be A over radical A, and that is radical A. And look at that. Isn't that saying L equal radical A, which equal the width? And if the length equal the width, isn't that automatically a square? So therefore, when the rectangle is a square.